Okay, good afternoon. My name is Nathan Gould, and this is my final project for Computer Science 185 Big Data Analytics. And today I'll be talking to you about Oozie, which is a tool that is built on top of Hadoop, and it was started by Yahoo, now managed as an Apache open source project. And Oozie is a powerful and extensible tool to manage the flow of a sequence of large-scale data operations. And so what Oozie can do is it can say, run a particular job at a particular time, and more importantly, run a particular job after another particular job is done, given a certain set of conditions, etc., etc. And Oozie can be put in charge of running map-produced jobs in addition to other types of jobs, for instance, Hive, Pig, streaming, as well as standard applications. So if you just have some Java program that you want to run in the middle of some other big data programs, then you can do that too. So Oozie is one of a number of alternatives for doing things like this, that is managing workflow. The most common one and the most simple one is cron. Lots of people know about cron. Cron can basically run a particular job at a particular time, but it's not much more sophisticated than that. It can't really interact with at all with DFS, so you have to do that on your own. And it also can't do the conditional execution that Oozie is capable of. And the other one is Azkaban, which is another common one that's sort of closer to the ecosystem of big data applications. And Azkaban is, according to what I read online, is a little bit simpler and a little bit easier to use, but probably not as extensible and not as powerful overall. So the organizing principle of Oozie is to represent your workflow as a directed acyclic graph. And a DAG, as I'll call it, is a collection of vertices and directed edges, in other words, a graph, that's configured so that one may not traverse the same vertex twice. So here's an example of a DAG from IBM, and they show you that you have a start point, and then you execute a pig job, and then you make a decision based on something, and you execute one of two map-reduced jobs, etc., etc. And you'll notice that you can't start at one place and end back up at the same place. So you can't do looping of any sort using Oozie. Oozie is just for workflows that start in one place and then continue, and then at some point they end. And each node in a workflow is a job or a script, or actually a decision. So and execution and branching can be parameterized by time, data availability, file size, etc. So I can say, if the data is there and it's after 2 p.m., then run a job. And the user specifies this process flow in an XML language used to that's defined for this purpose, to describe protocols for to describe process flows. So how Oozie works. So Oozie, like a lot of the tools we've seen in class, is an extra level of abstraction between the user and Hadoop. And Oozie operates its own server application with its own database. It uses Apache Derby by default, but it can also use MySQL, PostgreSQL, and Oracle, etc. And basically the way you run Oozie is you take your input data, you take your XML process description, as well as the jar files and any scripts that you want to run, as well as a properties file. And I'll show you how to make the properties file later. And you package them all up and you push them into HDFS. And it's once you've done that then you can invoke Oozie to run the entire job, or the entire job flow. And there's a couple ways to interact with Oozie. One of them is through the command line, where you can execute Oozie jobs like this example here. You can also use the command line to, for instance, validate your XML, or you can use it to start Oozie or to stop Oozie. And then there's the web interface, which is actually quite handy. And the web interface is actually optional to install, but I recommend installing it. So here's my Oozie interface, my Oozie web interface, and here's a list of a lot of jobs that I've run. And so you can do a bunch of things with this. Probably the most useful is you can look at the job log and view the stack trace. So if something went wrong, you can go in and see, find the error. You can see the the configurations you chose. This is the XML file that actually went ahead and ran the Oozie job. And this is a nice little feature. It will actually make a DAG for you based on how you specified the workflow. So that's the Oozie web interface. And so installation of Oozie is actually a very arduous process. Not just because there are 12 steps, as you can see, and then 2 configuration steps, and then a bunch of prerequisites that you have to do first, but also because there's a severe dearth of documentation for Oozie online. So, and that's made worse by the fact that some of the documentation out there is actually no good. So, Cloudera and you have to be careful. So, Cloudera and Apache themselves both have installation instructions for Oozie, but if you read, Stack Overflow and various other blogs on these technologies, then people say that the installation instructions on those websites are actually flawed in various respects, and that was my experience too. So I, unfortunately wasted a lot of time, but finally got it to work this way. So I'm not going to use time in my 15-minute presentation to talk about how to install Oozie, because it's a better subject for a PhD dissertation. But I refer you to my project document if you're interested in the steps that I found to work. So instead of talking about installation, we can move on to my example, which is to revive the homework 8 example where we have to make a histogram out of patent data. And if you remember, what we had to do was we start with a list of citing and cited patents, and then we had to turn that into a histogram showing the distribution of citation counts. And we broke that into 2 MapReduce jobs. So the first was inverter counter, which took in the input data and then output a list of the citing patents and the number of patents it cited. And then job number 2 took in the output from job number 1 and output the number of citations and then the number of patents that had that number of citations. And that's effectively a histogram, so you could plot that. But the MapReduce job just outputs the numbers themselves. And we've already figured out how to sequence these 2 things together using Java. So one way to do it is run one, then run the other, but we can use Java to say run one and then automatically run the other. But with Oozie, well, first of all, we can do the same thing. We can have it run one and run the other, but we can also do that with a twist. So the little twist that I came up with was after you're done running inverter counter, you're going to check the intermediate output. And if it's greater than 10 gigabytes, then you're going to give up and go to the end. And since we're not playing with 10 gigabyte data, you'll see that the thing executes anyway. But it's just, that's a little twist that I'm putting there to show you the power of Oozie over whatever the alternatives are. So the first thing you have to do to use this example is to get the required Java files, compile them, and jar them. And we can reuse the files from homework 8. And one thing you'll need to know is the class names. So we'll need to refer to that later on. And also be sure to grab the old API versions. Oozie supports both versions, but the example assumes that we're going to use the old API. Okay, so the second step is to write your workflow XML file. So here's an example of a single workflow XML file that executes a single MapReduce job, and that MapReduce job is specified under action name step 1. And so you'll see that when we start the job flow starts at the tag start 2 equals step 1, and so then it executes step 1. And when that's done, it ends up in one of two states, either in OK or in error. So if there was no error, then it goes to OK, and you can see in the XML that if it was OK, then the destination from there is end, and then it goes to end, and then the whole workflow is over. If there's an error, it goes to kill, which then ends the program as well. So this is the simplest of simple XML files. So inside the MapReduce tags, you're going to specify the job tracker, name node, preparatory actions, and configuration. And here's an example of how you can do that. And then within the configuration tags, which are inside of the MapReduce tags, you'd specify the properties that you would otherwise put in your main or run methods. So, for instance, you'd put the inverter counter map class, or the MapReduce output key class, which is text in this instance. So just to remind you, Oozie offers two kinds of workflow nodes. So one is action nodes, which you've seen, and that is perform a MapReduce or perform a pig script, etc. And the other is control flow nodes. So I've already shown you start, end, and kill. Those are the ones that are contained in most workflows. But then there's the sort of more powerful optional ones, which are fork, join, and decision. And we're going to use decision. Fork and join are ways of splitting up and then recombining workflow paths. Decision is kind of like an if-then construct, or actually a switch case construct. So this is the one we're going to be using in our example. And what this is going to do is it's going to say if the files contained in the directory specified have a total size of less than 10 gigabytes, then continue on to citation histogram. Otherwise, proceed to the end. And so we're just going to put that in our XML file. We can put it anywhere in the XML file as long as it's not in another action. So this is an action. This is a node of its own. It has to be outside of other nodes. But logically, or sort of intuitively, it makes sense to put it in between the two MapReduce actions. But it doesn't have to do that. And now what we're going to do is we're going to finish the configuration. So we have to create the properties file. The properties file is very simple. Really what it does is it specifies the location of the name node and job tracker, and also the path of the XML file in HDFS. And it defines any other parameters you want to use in the XML file. So here the only other parameter we use is the path. So the folder will be called histogram. But you can parameterize basically any variable you want. And step 4 is going to be to load the files into HDFS. So you actually have to use a particular file structure. Your properties in XML file have to be in a file in your local directory called histogram, and then there needs to be a subdirectory of histogram called lib, where that contains all of the jars. So once you've compiled and jarred the Java files that we're going to use, you put them in there. And then you're going to copy the whole thing into HDFS. And then step 5, at last, is to run your Oozie job. And you do that with this command. And then you can get your output in the same way that you normally do. So I won't make you watch me do that. And so to conclude, Oozie sacrifices simplicity for power and flexibility. It's a great resource because you can use it to run one thing in Hive, and one thing in Pig, and one thing in streaming, and one thing in MapReduce, and it does what it's supposed to do. But that comes at the cost of significant effort to install and configure it. It interacts with Hadoop at a network level, and you really have to understand the internals in a way that you don't have to understand with, for instance, Pig. So I've compiled some useful references, and that's what I've got. Thanks for listening.